this angle at this given point. How are we going to find this angle here? Is the fact that we're going to use the property that a radius, this part is also 6, is going to form 90 degrees with the tangent AB. So which means that this angle on this side, we can call it angle beta. We can be able to find it, and then it will enable us find this other angle on this side. So before we look into that, let us find angle beta. And since this angle is opposite to this side and adjacent to 6, so we can now say tan beta is equals to opposite over adjacent. So this is going to be tan beta. Beta is just a symbol to represent an angle like theta. We are going to say opposite is 8 over adjacent, which is 6. So which means that beta is going to be equal to the tan inverse of 8 over 6. So if we work out this, let's see what we are able to get. We are going to substitute this 8 and this 8 into the formula in order to work it out. Remember, we are going to say this is a tan inverse of 8 over 6. If you work it out using your calculator, you're gonna get the angle in radians. This value is 0.93. So we are going to say this is 0.93 radians. 0.93, we can be able to work out the value of this angle on this other side here. Because this is a straight line, then we can say now this is going to be our angle theta. So theta is going to be pi, which is 180 straight line, minus 0.93. If we work it out, this is pi minus the answer, we're going to get 2.21. So this is 2.21 radians. So the angle that we have at this given point is 2.21 radians. So meaning that for us to find the arc length, we can be able to apply the formula. Arc length S is going to be R theta. So which is going to be 6 times 2.21. If we work it out, I'm going to put this in the calculator. Then this is going to be 6 times 2.21, which translates to 13.26. 13.26 centimeters. That is now this particular part. So next, we need to know what is the length. Remember, this is a right angle triangle at this given point. So we can be able to use Pythagoras theorem in order to work out AO. So we can say AO is equal to the square root of, this is a shorter side, this is a shorter side, so AO is the hypotenuse. So we're going to say this is going to be 6 squared plus 8 squared, which is equal to the square root of 36 plus 64, which is equivalent to 100. Square root is actually 10 centimeters. The square root of 100 is 10, so meaning that this dimension here is given actually as 10 centimeters here. But for us to find perimeter, you need to remember that perimeter is distance or round. So meaning that in order to work out this perimeter, we're going to say perimeter is going to be this part, we got it down up in 0.26 plus this part 8 centimeters plus 10 centimeters, then plus 6, because now up AO is 10 plus 6, which is the radius, plus 6 at this given point. Let's see what we are going to get. So that is actually 13 plus 8 plus 6, then plus 10. I'm getting my value as 37.26. This is 37.26 centimeters as the perimeter. Okay, now once we have this perimeter, The next question of interest at this given point for part B is to work out the area of shaded region. Now, in order to work out the area of this shaded region here, I'll work out the area of the right angle triangle. I have r squared theta. So I'll say I have times 8 times 6. I'll work out that, and then I'll say I have times 6 squared, because the radius of this sector is 6, then times the angle, which is 21, rather times the angle, which is 2.21. Then I'll enclose like that so that we can put that information in the calculator. So I'll say this is 1/2 times 8 times 6. I'll close the bracket, then plus open bracket 1/2 multiplied to 6 squared multiplied to 2.21. So I'm going to get my answer correct to 4 significant figures. My answer is actually 63.78. So the answer here is equals to 63.78 centimeter square. That's what you're supposed to do in order to work out questions like this, right? The perimeter and the area of the shaded region. The information that was provided in this question is that O is the center of this circle. So O represents the center of this circle. So you can say this is a circle of center O, and the radius of this circle is 10 centimeters. AB is 15 centimeters. DC is 10 centimeters. So how are we going to work out this question in order to work out the perimeter of the shaded region and the area of the shaded part? So for us to work out this question, the first thing that we need to identify is the B, and also join OA like that. So since we are told that the radius of this circle is 10 centimeters, so you can say this is actually centimeters, and this point is 10 centimeters, because both of them are representing the radius. So if we drop a perpendicular right from this given point, if we drop a perpendicular, let me just try to draw a perpendicular here. If we draw a perpendicular right from this given point here, we are 7.5 centimeters. Then we are finding this angle at this point, which is theta. Of course, this is 90 degrees. Huh? So say, because we are having hypotenuse and opposite to this angle, then we can say that this is sine theta is equals to opposite over hypotenuse. So you can say sine theta equals to opposite, which is 7.5, hypotenuse, which is equivalent to 10. Then we can now say our theta is going to be equal to sine inverse 2. I'm going to get my answer as 1.